Good evening, everybody. Today I will be explaining how to import your 3D model developed for a design project, for example, into an online tool. The online tool that we are going to use is called andrewmarsh3d.com slash sunpath3d. The sun path will be displayed for a specific location, and you can see the shadows casted by the buildings. You can also explore the site area and as well your building located on the site. This is a building site taken from the UNESCO location, and we have worked on this site in previous exercises, especially in the worksheets that we developed in class. I guess you are familiar with the site area. It's located nearby the UNESCO building, the Ministry of Education building. It's here. And this is the 4 Points by Sheraton Hotel, which is facing the lot. The lot is quite large area located in the center of Beirut, and it's about 8,000 square meters. Using Rhino and Grasshopper, I developed the 3D model of the site. And as you know, Grasshopper is a parametric tool that allows to display the 3D sun path regarding a specific location with shadow analysis in real time. Later on we may be covering the tool and how to use parametric modeling. For today, our objective is to import the 3D model into the object OBJ format and use it in the available web-based tool by Andrew Marsh. So your task by the end of this video lecture will be as follows. So you will be converting a 3D model of an area taken from your design studio into the OBJ format. Rhinoceros 3D has the export option into the OBJ format. You have to explore the 3D modeling tool that you are using and make sure it has the export option into the OBJ format. It's a format that is accepted by the online-based tool regarding the 3D sun path. Then you are going to upload the model into the online tool and display the shadows for different days and times. Okay, once we are done with importing your 3D model and analyzing the shadows of your area, of your project area, you are going to save screenshots as proof of your performance. And these screenshots of the web-based tool, including your 3D model, are going to upload it on Blackboard in a folder that I will create appropriately for this exercise. As I have mentioned earlier, you can use whatever 3D modeling tool that have the export option into the .obj format. Rhinoceros 3D has this option. If you are interested in learning Rhinoceros, I have developed video tutorials regarding the use of Rhinoceros, and I will be happy to share them with you. So from the file menu, you can use export with origin option. For sure, you have to select the objects of your model, and these should be 3D objects. So in this format, only 3D elements, solids, will be imported. Single lines are not going to be recognized by the exporting format. So for example, in this case, in order to have the lot area visible, I turned it into a surface, and I gave it an extrusion value, so it became a solid. In this way, the surface could be exported. As well, the street network could be given an extrusion thickness or height, and will be recognized by the exporting tool. Once you export your 3D model into the OBJ format, save it in a folder and give it an appropriate name. As you see, the OBJ format will have the .obj extension. The 3D SunPass available in the Grasshopper plugin of Rhino is as well available through the web-based tool. So it's a user-friendly option to get access to the 3D SunPass without downloading any software. I already showed you the SunPass, 3D SunPass using Grasshopper. And our task today is to use the web-based tool in order to have the shadow analysis of any site. Once you access the link, okay, you need for sure an internet connection, a stable internet connection, since the tool is not a software that is downloaded into your computer or into your laptop. It's a tool available through the server. So once you click on the link, andrewmarsh.com, the link shown here, and you can Google andrewmarsh.com SunPass 3D and have access to the tool. This is the screen that is displayed. First of all, you have to set the location. So we know that the SunPass changes according to the location. The default location is the United Kingdom, and you can see the SunPass related to more or less center of United Kingdom. We have a low sun in the sky. This is the March, as you see here, the date and time, March at 10 a.m. You can see how low is the sun in the sky. On the right hand, you have the azimuth and altitude angles of the sun. We have already defined these two angles. The azimuth 145 degrees, which is the measurement from the north axis. You know that these are 90 plus 55. Okay, so it's 145 degrees sun inclination from the north axis, while the solar altitude angle is the angle measured from the horizontal plane and represents the height of the sun in the sky, and it's 31 degrees above the horizon. We are going now to change the location into Beirut. So from the location, from the map, you can surf the map. Okay, Beirut, Lebanon. Zoom in using the wheel mouse, and I can locate the pen exactly in the area, in the building project area. so which is the UNESCO area. UNESCO, okay, UNESCO here it's visible, and the area is on Saib Salam highway, and if I'm not mistaken will be it has a triangle shape. It's between UNESCO and Saib Salam. Okay, clear. This is the area with this triangular shape, and it's about 8,000 square meters. Double click on the area and you will be locating your building project. On the right hand you can see the immediate update of the sun path. We can see Beirut location, which is 33° north latitude. Here I can extend my geographic location information, and this is the 33.88 degrees north latitude of Beirut. As well, the date and time showing, and date and time could be updated in this screen on the left hand as well. And you can see how the solar altitude angle changed. So as we remember, in center of England, it was about 30 degrees from the horizon, the solar altitude angle for the same date and time. For Beirut location, it's 52 degrees. So there are 20 degrees difference in the solar altitude angles. And this will for sure impact design. So the first part of the semester, the solar angles were explained, and an explanation of how solar angles or solar geometry will impact building design was also performed and supported with case studies where sustainable buildings were explored, and the sun path in all these buildings was taken into consideration, and this defined the building orientation, the amount of glass on the facades, depending on the facade orientation. Our next step is to import the 3D model of your project area. So you have to click on the icon shadow model with a building drawing on it, and load OBJ, STL or PLY. Okay, so our building model is in the OBJ format. Click on load, and you have to select the saved file in OBJ format and click open. Okay, this is the model that I showed you in Rhino. For sure here it needs adjustments. It's simple. You have to click again on the shadow model icon and select swap Y and X and Z axis. Okay, so it's not the correct orientation of the model. Again, try again, and try again. Okay, now we have the correct orientation of the model. The buildings as well are dark. We need to reverse the normals. So you have also a reverse normals option, and now it looks the way we want. Make sure you have the correct north orientation of the site. We know that this is north and this is south. As I mentioned, the UNESCO building, this is the building, UNESCO building, one of these, I don't remember. And this is the 4 Points by Sheraton Hotel facing the area. Once you have imported the model into the web-based tool, you have to save 3 to 4 screenshots of the screen and change the dates and times. For example, for the first screenshot, I'm going to set the summer solstice, which occurs in June 21. As you see here on the left hand, I can set the date and the time, 12, 11, whatever timing you want, 12 p.m., 11:30. You can see how high the sun in the sky. We have a solar altitude angle around 80 degrees. It's very high sun in the sky on June 21. Save the screen, save the file, and this is your first screenshot, for example. You can as well change or orbit the view by using the right mouse button. You can use the combination of right mouse button and control key to zoom in, zoom out. The combination of right mouse button and shift key to pan. You can as well change the view into a parallel projection, axonometric view, perspective view. This is a parallel projection, axonometric. This is a perspective. You can as well go to a top view and see the shadow and the sun path in a top view. You have to explore different views, different dates and times, and different shadow analysis. As I mentioned, at minimum 4 screenshots, and that will be uploaded on Blackboard as your first exercise regarding this video tutorial. Good luck.